Discriminant greater than 0. What does this imply? Plus discriminant more than 0. What does it imply? Two real and distinct roots. So we know that roots are solutions. And they are also, as we have shown over here, points of intersection, right? Right? Okay. What happens when discriminant equals to 0? What does this mean? Two repeated real roots. Okay? So again, roots will be our solutions, which is our points of intersection. Okay, and finally, we've got discriminant less than 0. What does this mean now? No real roots. Roots again will be solution, which is our points of intersection. Okay, why do I want to write all this down? Take a look at the first case, where we have two real and distinct roots. I want silence before I continue. So two real and distinct roots, meaning two solutions. How many points of intersection do you think there will be? In this case, how many? 2 points of intersection. Look at the graph. Do I have 2? Yes, right? Okay, second case, discriminant equals 0. 2 repeated real roots. So roots are a solution, which are the points of the intersection. How many points do you think there are? 1. 1 point of intersection. Last case, no real roots. How many points of intersection? 0 points of intersection. Easy or not? Okay. So let's move on. This time, we are no longer talking about only the x-axis being my straight line. This is my x-axis, which is known as y equals to 0. Okay, earlier on we always been using this. Today we've got other cases. I've got a parabola like this. Y equals to ax squared plus bx plus c. Okay, obviously a is going to be greater than 0 in this case because it's a parabola opening upwards. Now I have a line. For example, like this. Y equals to 3. Okay, so I've got equation number 1 and equation number 2. If I were to solve them simultaneously and I get 2 values, how many values of x do you think I'll get? If I solve these 2 equations simultaneously, equation number 1 and equation number 2, how many values of x do you think I'll get? Where are the 2x values? Why y equals 0? They are both at y equals to 3. Okay, and the results for x are over here and over here. Am I right? Okay? Okay so far? Now today if I change this to become y equals to 5, how many solutions do I get? 2. Still 2, right? What if I change this to y equals to negative 100 and this is my graph? How many solutions?
0.
Why 0?
Because it doesn't hit the graph.
What do you mean it doesn't hit the graph? It's still intersecting the graph, isn't it? Look at the 2 graphs. I've got y equals to ax squared plus bx plus c. That's equation number 1. That's the parabola. I've got a horizontal line of y equals to negative 100. How many points of intersection are there? 2. How many solutions are there? 2. Okay. As long as I've got 2 points of intersection, they are going to be my 2 solutions if I were to solve them. Can so far? If I solve equation number 1 and equation number 2, okay? What happens if you try and solve these 2 simultaneously without using a graph? What will you do? What will you write? Then what do you have? Ax squared plus bx plus c equals to negative 100. Yes, if you were to try and solve this, then you will get x1 equals to something, x2 equals to something. Okay, we are expecting 2 answers because there are 2 intersection points. Okay so far? Next case. I've got again a parabola y equals to ax squared plus bx plus c. This time my straight line looks like this, no longer horizontal. I give you a slanted one. Okay, let's call this y equals to mx plus, oh I cannot use c already, right? Let's use d. Y equals to mx plus d. Can? So I've got a curve and a straight line. If I were to solve these two equations simultaneously, how many values of x do you think I'll get?
2.
Where are the two values of x?
4 intersection.
Over here, over here. So just drop down to your x-axis and see what are these values. This is x1, this is x2. Make sense so far? Yeah. Because there are 2 points of intersection, meaning 2 solutions, yeah? Okay? So what if my graph doesn't slope this way? What if my graph slopes, what if the graph looks like this? How many points of intersection?
2.
How many values of x?
2.
What is the sign of the discriminant?
Positive.
What is the discriminant again?
B square plus 4ac.
B square minus 4ac. Minus 4ac, okay? But, if I were to solve these two, what do I have simultaneously? What will you write? Okay, mx plus d equals to ax squared plus bx plus c, right? And then if I want to continue solving it, how do we do that? Which one do you want to use? Factorization, completing a square, quadratic formula, which one? Really, factorization? Formula. In order to use the formula, can I leave it like this? No, I need to arrange all the x squared, all the x, all the constants together, right? Then it must be equal to 0. Then I can use the formula, right? Okay, so let's see what happens. I've got ax squared plus bx minus mx. Actually, it's just the laptop got problem. It just zooms in and out by itself. Ax squared plus bx. What am I writing? Ax squared plus bx minus mx plus c minus d equals to 0. Agree?
Yeah.
So, what is the discriminant? Is it b squared minus 4ac? Okay, rewriting it. Ax squared plus b minus m x plus c minus d equals to 0. What is the discriminant?
B minus m squared minus 4ac minus.
Okay, what can you tell me about the discriminant over here? In this case, there are 2 points of intersection. So this must be greater than 0. Okay? So now I've just shown you what happens when a straight line intersects a curve, a quadratic curve, at 2 different points. When that happens, we are actually trying to solve simultaneous equations. When you try and solve simultaneous equations, you will naturally want to use quadratic formula because no guarantee that it can be factorized, right? So because you want to use quadratic formula, you are going to want it to be of the form like this. Something x squared plus something x plus something equals to 0. We always want it to be that way. Am I right? Okay. So this is for case number 1. That is shown on page 68, case 1. Top left hand corner of the textbook. Look at it. After talking so much, the summary is you cut at 2 real and distinct points. The discriminant is greater than 0. Okay? Now what happens if it is case number 2? So I've always been drawing parabolas opening upwards. Now I'm going to draw a parabola opening downwards. Doesn't matter. Okay, this is a parabola opening downwards. What if it touches a straight line like this? Touches only, What can you tell me about the discriminant?
0.
Equal to 0. Because this could be a case of y equals to negative x squared plus 5x minus 1. I do not know. And then over here, this could be another equation, y equals to mx plus c. Okay? Y equals to mx plus c and quadratic over here. These two, if I were to solve 1 and 2, I will get one single value of x. X equals to something. Only one value. That is because there is only one point that the line touches the parabola. Okay? Where do I get the discriminant from? Is the discriminant equal to 5 square minus 4 times -1 times -1? Is this the discriminant? No, it is not. You have to solve equation 1. You have to put equation 1 and 2 together. Then you find the discriminant. And the last case, by extension, you should know that the discriminant is less than 0. Okay? So now I've completed the intro to 2.5. Tomorrow we will finish it. 2.5, and we will go on to graphs of modulus functions.
So, can you don't give